here's a planning video for SNC1W. This is science class D-Stream grade 9 in Ontario. Every summer, I take some time to reread the curriculum from the government. So we're going to do that today, and I'm going to give some input as I read it. It's always good for either new teachers to understand the curriculum, but second, for veteran teachers to realize that the curriculum change every so often, and therefore it's important to make sure that we understand what's going on. So we're going to look at the curriculum. We're going to read through the 5 strands, and I'm going to give some input, some ideas I'm planning to do for this semester. So enjoy the reading with me. So here is the beginning of the science curriculum. It goes like this. This course enables students to develop their understanding and concepts related to biology, chemistry, physics, and earth and space science, and to relate science to technology, society, and the environment. Throughout the course, students will develop and refine their STEM skills as they use scientific research, scientific experimentation, and engineering design processes to investigate concepts and apply their knowledge in situations that are relevant to their lives and communities. Students will continue to develop transferable skills as they become scientifically literate, global citizens. So some of what we're going to plan this year is to build scientific literacy. So that will be exciting. So here there's a whole curriculum, and I will put in the description below the link to these. So there's a whole section here they called the front matter of curriculum. We're going to look at expectations by strands. The beginning part is about pedagogy, some of the philosophies of the course. I might look at reading that with you if you, in the comments below, mention that you'd like me to do so. But the plan for me is to look over the strands so that I can get better for this coming semester. So here by strands, there are 5 strands. We've mentioned that before. The first one is about STEM skills. Second will be biology, then chemistry, followed by physics, and to end with earth and space sciences. Now, in a semester, you don't have to go into that order, and I'll explain to you more or less what I'm planning to do this semester. So here, what do we have about STEM skills, careers, and connections? So this one here, some teachers are keeping a 2-week block at the beginning of a semester so that they can look at STEM skills and connections. I tend to start my first unit. So usually within 2 or 3 days, I'm right in going with course content, but I'm including the STEM skills in each of the units. For me, it's more applicable, and it's great that way. So let's see what are these skills here. So the course, the curriculum works with overall expectations, and it's divided in 2 parts. So the first one here is part A1 on STEM investigation skills. So here, apply scientific processes and engineering design process in their investigations to develop a conceptual understanding of the science they are learning, and apply coding skills to model scientific concepts and relationships. So let's see what are the specific expectations here for this first part. So here we're going to look at connections, and it goes like this. Can you see it nicely? Let's see if I can put it a little bit bigger. Is it easier to read? Oh, maybe. Let's see. Can I make it even bigger? Oh, maybe it's better this way. Okay, so let's see what we've got. So these are the specific expectation for the first part called A1. So the first one, apply a scientific research process and associated skills to conduct investigations, making connections between their research and the scientific concepts they are learning. So here the plan is always with projects. A project where they have to gather information, answer questions. They can publish their what they find into infographics, presentations, posters. There's a variety of them. So here, my plan for this semester, they're most likely going to be a project in maybe in sustainable ecosystems, maybe with let's see, one of those organisms that are let's see, I forget the word now. Invasive species, there you go. And then maybe one based on astronomy, because astronomy and space exploration changes all the time, very fast. And I think it allows students to do something they like. The second part here is about apply a scientific experimentation process and associated skills to conduct investigations, making connections between the observations and findings in and the scientific concepts they are learning. So for this one here, this is for me labs. So we're going to do several labs in chemistry. There's always one in a few in what we called in electricity. I like to get all the equipment out. They have to put a circuit together, especially for people that have not done it. And I always give a chance for students to either continue with the hands-on activities and equipment, and eventually I also add some simulations so they can gather data and analyze data. So we'll see how it goes for this one. Apply an engineering process design process and associated skills to design, build, and test devices, models, structures, and or systems. For this one here, for this year, I'm going to try something I haven't tried before. I'm going to see if I can use small motor to see if they can create little race cars. So that's just what I hope to do. I'm not sure exactly how it's going to turn out, but we'll see with that. Now, what's interesting on this one, I hope to be able to include some coding so that I can add some logic in their car. For example, when they start, maybe a couple seconds delay, then they go forward, they turn off maybe the energy through fans, and then start again. Well, we'll see how it goes. My hope is for them to create a few designs so we can include circuits into their design. I think that will be fun. The next one here is apply coding skills to investigate and model scientific concepts and relationships. So for this one here, my hope is to look at simulations, but also if we can find a way to do some coding skills with either blocks so they can achieve something specific, maybe even some vibe coding. We'll see how it goes, because I tried Claude coding this year, and they can come up with nice little apps in the HTML format that they can put into a website, and I think that could be fun for them. So this is something I'm going to try again this year. The following here is apply the knowledge and understanding of safe practices and procedures, including workspace hazardous material system, or WHMIS, and while planning and carrying their hands-on activities. So often people mention that in chemistry, but it applies to all aspects of science, especially when we have cleaners, when we have electrical circuits or electrical energy, when we are working outside in ecosystems, spills. So there's a lot of things to look into. So this is here the first STEM investigation skills. Let's look at the second part for this one. The second part here goes like this. So as I say, I'm reading through the curriculum, giving some insights, some ideas. It's getting my brain going slowly. If you have any questions related to what I'm planning to do, or if you have any ideas you would like to try, put it in the comments below, then I can improve even what I do, and that'll be great. So for the second part here, we have applications, careers, and connections. Analyze how scientific concepts and processes can be applied in practical ways to address real-world issues and in various careers, and describe contributions to science from people with diverse lived experience. So let's see how it goes. So here we have A2, and they go like this. So it's about applications and careers and connections. So the first one here we need to design an experiment or prototype to explore a problem relevant to STEM-related occupations, such as skilled trades, using findings from research. So for this one here, I hope to use that car that with a fan, a motor, small circuits. So I hope that it will work nicely. Second one, describe how scientific innovations and emerging technology, including artificial intelligence systems, impact society and careers. So for this one here, space exploration works very well. And a few years ago, and I'll see if I can find it again, there was an app where we could train an AI to identify materials, especially when we want to, the idea here was if you want to recycle materials, you need to train the AI to know if the object is a bottle or it's not a bottle. So I'll need to see that, because when you think of training AI, you need to give them as much information, and the more it has, the more precise it can be. So I'm going to see if I can add that as well. We're going to have analyze how the development and application of science is economically, culturally, and socially contextualized by investigating real-world issue. Now, keeping in mind that I'm in Canada, so the resources I have is different than other countries, different continents, depending on the seasons as well. So right now is the summer in Canada, but it is the winter in other countries. When it is in mid-February, when it is minus 15 outside, minus 15 degrees Celsius, I cannot do the same thing then in the fall, depending on the temperature. So that's something to look into. Next one, we have, there you go, apply scientific literacy skills when investigating social and environmental issues that have personal, local, or global impact. So for this one here, I'm going to most likely include the difficulties that Canada and many countries have had this summer, which means a drier environment where we have more forest fires. There are places where we've had some typhoon that has been very hard for some countries. And so we're going to see how it is. Personally, outside my house right now this year, the grass is still green. Usually it's sunburned by the time we get to mid-July. So in this part of the country here, closer to Toronto, a lot more a wetter summer compared to other places around the world. So here I'm going to see if I can add to that. And 2.5, we have analyzed contributions to science by people from various communities, including communities in Canada. So including let's see, First Nations, including new immigrants coming to Canada, and communities across Canada. Canada is a huge country. We're going to see if I can get any examples from different parts. And this is what we've got here with the first part of our course this year on STEM skills. Now, we're going to look into the 4 units that we have this year, and we'll see what we can get. So here is the second unit, the first content unit in biology. Now, keeping in mind that the STEM skills I will include in each of the units, I think it's better for the classes. Now, this is my perspective. If you want to do it a bit differently, that is up to you. I know that I worked with a colleague where last year, by the time they started their first unit, was already the second week. No, it was the beginning of the 3rd week of the semester when they started content. They did a great job in looking at STEM skills at the beginning of the semester. However, she felt behind for the rest of the semester. So what I usually do, as I mentioned earlier, I start content within the first couple days and I include all the STEM skills as we go along. So we are learning the skills with content, and I think it allows students to understand. It gives us maybe a couple more weeks to do more content, and for me it works nicely. So give it a try to see how things go, and if you have any questions, put them in the comments below. So let's see if we can continue. Biology at this time, it's the idea here of sustainable ecosystems and climate change. So the last part here is something new since 2022, because it was not a part of the curriculum before that time. So it's created some changes in the curriculum, and that's why reading the curriculum that you're teaching is important. So here in biology, we're going to have the first one about relating science to our changing world. Let's look at these specific expectations. Here we will assess impacts of climate change on ecosystem sustainability and on various communities, and describe ways to mitigate these impact. So let's see. So we go like this and B1. So here the first one. Assess impact of climate change on the sustainability of local and global ecosystems. Describe local and global initiatives for combating climate change and identify solutions to address some of the impact. Now here in 2026, this summer, And in the last few years, there's been a lot of forest fire, and it affects the forest indeed, but also all the microorganisms and animals in those forests, including some of the towns and cities close to the forests, where humans and cities are affected by the smoke. So all these things are important. Now, there are forest fire where there are a lot of forests. So that means that First Nations are often the most affected, and they have to be flown out or moved out of their living area, and it's not always easy for them. So we're going to include that as part of what we're going to do. But also will include parts where temperatures are changing. Some places we have a colder weather, whereas colder weather than usual. Some other places hotter, some places drier, wetter. There's so many things we're going to be including here. And the idea here, it's always the address the impact. Often we think of the impacts on humans, but we have to think about the impact on the ecosystems, on the environments, as well as our atmosphere, where we are all sharing that. And my hope is not to include too much geopolitical issues related to that. Second point, assess impact of climate change on communities in Canada, including First Nations, Métis, and Inuit communities. I talked about this a little bit. So here in Canada right now, Ontario, British Columbia, and Northwest Territories are having a lot of difficulties. And this is on August 10th, 2026. But last year, we had similar issues, and that in many countries. In Europe, it's not very easy at this time. But here, we're going to have a focus on Canada. The third bit, investigate and explain how sustainable practices used by various communities, including First Nations, Métis, and Inuit communities, reflect an understanding of the importance of the dynamic equilibrium of ecosystems. So the idea here is to look at the know-how of different communities so that we can all help our community and our communities and country. Because if you don't ask questions, good questions, often we forget. And you know what? First Nations have been here for thousands of years. So let's see. We're going to go to our second portion. And the second portion of this one, let's see if I can go. It is part B2, and it's called Investigating and Understanding Concepts. So for these ones here, we will demonstrate an understanding of the dynamic and interconnected nature of ecosystems, including how matter cycles and energy flows through ecosystems. So here there's been several changes in the curriculum since 2024. So let's see what are the concepts to look into. So first, investigate the interactions between the biosphere, hydrosphere, lithosphere, and atmosphere, and explain how these interactions are important for ecosystems and sustainability. So this one here, it's one of my favorite topics. Now, they've seen in grade 7 or 8 topics like biotic and abiotic factors. So that's a portion I don't have to include in this unit. We can just review it though. Next one, explain how naturally occurring phenomena, including the cycling of matter and flows of energy, contribute to the dynamic equilibrium within and between ecosystems. So for this one here, we're going to look at the different cycles in the environment. So here we have the carbon cycles. We also have the nitrogen cycles. I might add the phosphorus cycle for more advanced students. Now, they've seen in the past the water cycle like there's no tomorrow. So I might make it like a diagnostic activity, but I'm not going to spend a day on the water cycle and try to see how it goes. And here we're going to look at the dynamic equilibrium, including some of the, how we call that? All the farming, the way we farm our food in Canada, because we have to be mindful that the more you are producing food, the more you are putting strain on the ecosystem. So we're going to look into that. B3 here, B2.3, compare and contrast the processes of cellular respiration and photosynthesis and explain how their complementary relationships contributes to the dynamic equilibrium of ecosystems. So for this one here, my plan is to talk about both concepts, cellular respiration and photosynthesis, and I'm going to most likely start with this unit in September. So that means that I hope to go outside. I've always have different activities for lab skills. And I think this year I'm going to do one activity I did, I think it's a year and a half ago on the question was how many leaves, no, what is the total surface area of available for photosynthesis on a given tree? And what's interesting with this one is that there's no one answer for this. So for this one, the students will have to choose a tree. They'll have to draw on a grid paper at least 5 leaves. So I'm not going to ask them to pull the leaves because when you pull leaves out of a tree, they no longer can use it for photosynthesis. Then they're going to look at surface area for those leaves. Now the beauty with that, it gives students a chance to do some, to use graphing paper to figure out the size of the leaf. I know though that some apps are useful with phones, so that's something they can use. They can also look at graphing skills. They also look at trends to try to see if they have the surface area of 1, 2, 3, 4, and 5 leaves. Can they find the total surface area of all the leaves of a tree? And that becomes an estimate because the estimates of every student will be different for the same tree. So that's beautiful because it gives a chance for students to gather data, and it's important. The more surface area is available, the more photosynthesis is possible, and the more the carbon cycle can be included. So we're going to work into that and gives us a chance to be outside as well. So that is one of the lab I like to do, and I will most likely do this year. B2.4. Investigate factors and processes including biodiversity, air and water quality, soil health, and succession, and explain how they contribute to ecosystem sustainability. So for this one here, it's about soil health. So what we're going to try to figure out will be, I will most likely include some chemistry for this one. So here you can think of the nitrogen cycle. I hope to be able to include some point of air quality because nowadays we have amazing website with air quality in the atmosphere. Especially for us, we've had air quality reports all summer with the forest fires. But when you're in a city, you can have the smog. There's a whole bunch of different things, and I hope to be able, if everything works well, to go to the creek at the back of the school to take some water sample. We'll see, but here in all safety, making sure that the students don't get hurt. Next one, we have B2.5, explain the effect of various human activities on the dynamic equilibrium of ecosystems. So for this one here, we're going to look at the idea of urban sprawl. We will also look at how we have the world population increasing, which means that we have more need for room, for food, and there's more waste being created, and we need more water, clean water. And this can bring some disequilibrium, there you go, of different ecosystems. So I hope to be able to include ideas and topics from the area where we are at. Always keep in mind that if you can find ideas and examples from your living area, students can relate to that a lot more. And what I might do on this one here, I might do actually a photo contest where they will have to go into a city, maybe a weekend, take a photo or two so that they can show to the class and present how humans are affecting their immediate communities. I think that would be fun. Very nice. Next one. Identify and use various indicators of climate change to describe the impact of climate change on local and global ecosystems and analyze how human activities contribute to climate change. If I remember well, this one here, so when this curriculum came up, they wanted to focus on local areas. That meant Canada. Now here they're including global ecosystems. Now what's interesting for this one is that it goes in line with the grade 10 curriculum that we have here, because they haven't changed it yet. Now, keeping in mind that the climate change ideas came up 2 years ago in the 2022 curriculum, but there's a whole unit on climate change from the grade 10, and that was created in 2008, which is many, many years ago. So that might change at some point, but I do include a graph on overall temperature, increased temperature of the global temperature of the planet, and how our human activities can contribute to climate change, but also how climate change is affecting human activities as well. So that is very important on this one. And the last one here, explain how sustainable practices relate to the cycling of matter and flow of energy can be applied to agricultural innovation. Now that's important because if you have a good agricultural economic industry that allows everybody to have to eat well, but also bring money in an area. So it is changing, especially with climate change, because change in temperature and humidity can affect that. Now I'm going to have a quick look as well for the sustainable ecosystems and climate change with topics they've covered in grade 7 and 8. So you can see some topics that the students now have that you don't have to include in your class, or at least have some diagnostic activities and not do full-fledged lessons. So from the grade 7, what they do is that they have a whole section on ecosystems, as well as interaction between living organisms, including food chain, including primary and secondary successions, and biotic and abiotic factors. So I remember in the past curriculum, I would spend a couple days on this. So that frees up a few days for me to do new ideas and new activities. In grade 8, in the unit Earth and Space Systems, they do talk about the water systems quite a bit. That includes fresh water on the planet, availability or difficulties of abilities, and demonstrate an understanding of First Nations, Métis, and Inuit knowledge about water. So that's something they've covered, so you can bring it in as an introduction for your unit. They also do in grade 8, they talk about the water system. So this one is all about the water cycle, as well as the importance of it, where it exists, and importantly, the circulation of water. They also talk about atmospheric conditions, which relate to meteorology, and also phenomenon on local and global systems. Now, the idea here is that if they've covered the topics, you want to use it to start and engage the students. If you notice that they haven't, then you may have to bring some of those topics inside the class, especially if a student has just moved in your area this summer, last year, or 2 years ago. Now, there's also in grade 6, they've talked about life systems, and this one is about biodiversity. So students have talked about biodiversity for a long time, and therefore it's something to keep in mind. So use your students to tell you what they've learned, what they found interesting. Always keeping in mind that the interval of understanding on the topics will be different from different students, especially if they just came in to your school, they just moved in, they're from another country, there's some language barriers, so a lot of different parts here. So this is the biology unit. Let's see what is the next one, and I think the next one is chemistry. This next unit is about chemistry, so let's see what the plan is for the grade 9 class this year. So it's called The Nature of Matter, and it is the introduction of pure substances related to the periodic table, elements, and compounds. So let's see what we're going to learn. In this strand, students integrate learning from strand A, which is on STEM skills, as they investigate concepts, develop and apply skills, and make meaningful connections to their lives, their communities, and the environment. So let's see if we can look at the first one. The first one relates science to our changing world, and therefore we assess social, environmental, and economic impacts of the use of elements, compounds, and associated technologies. So let's see. So only two specific expectations here, and they go like this. For the first one, assess social, environmental, and economic impacts of processes associated with the life cycle of consumer products, considering the elements and compounds used to make them, and suggest ways to enhance positive impacts and or minimize negative impacts. Now, this is very close to a topic that is covered in geography in grade 9 when they look at how the industries are creating goods in their environment. So here, what's interesting, we have the life cycle of consumer products. This one here. Now, in my geography class, often what I do, I take a pencil, like a wood pencil, and I bring some tools, and I get the students to take the pencil to separate the eraser, the metal tip, to take the paint out of the surface of the pencil, the wood core, as well as the lead inside where we're using for writing. And then we can look about how the forestry industry, the mining industries are involved in all of these, including putting it together and moving them where they're needed. Now, with respect to the cycle of consumer products here in science, what I might do is I might use their phone. All the students have a phone, one way or the other. Some of them are more advanced than the other. And I'm going to see if we can look at a cell phone. And therefore, if you think of those, what are the elements and compounds that are needed for the screen, for the battery, and for the different parts, so that we can look at the impacts of getting the resources, but also using them, but also when we dispose of our phone. I always do a graphing activity for this one. And the question is, how many phones do we have? Now, how many phones our families have in this class? So usually I ask each student, how many phones or cell phones do they have at each of their home? And some students will say there's one. Some people, the kids say, I have one and my parents have another one. So sometimes there's 2, 3. Some places where you have a family where you have three kids with 3 phones, and then you got a parent with a phone, and you have a work phone. Some household have several of them. And then what we do is that we graph how many phones we have in a classroom. And then if our class is about maybe 30, then you realize that with 30 students, we have a big number of cell phones that we have purchased. Now, keeping that in mind, that if you have one class, you multiply it by all the classes in your school, then you can take your region, your province, and even the country. Then you realize that for cell phones, it's in the billions when we think of a worldwide account of those cell phones. And that just to help students realize how much resources we need for that. Next one, analyze impacts of using emerging chemical technology in various fields, including the skilled trades, and assess factors that influence the development of these technologies. Now, keeping in mind for this one, we use chemistry to help humans to do things. However, we need people to create them, to move them, to use them, and dispose of them. So I hope to be able to help them with that. Let's see what is the second part for this one. In chemistry, we have C2, and this one is investigating and understanding concepts. So demonstrate an understanding of the nature of matter, including the structure of the atom, physical and chemical properties and common elements, compounds, and the organization of the elements on the periodic table. Now, this has not changed very much from previous curriculum. So let's see what they've got right here. So the students will, in this segment, and you will recognize that for the ones that have taught this course. Otherwise, if you're new to teaching grade 9 science, you'll see lots of good fun. C2.1, investigate properties, changes, and interaction of matter that are important to dynamic equilibrium of ecosystems and their sustainability. So here, looking at the three states of matter, liquid, solid, and gases, especially in the winter. For us in Canada, in the winter, it's very cold. You cannot have a plant with photosynthesis unless you have an evergreen tree, and that is still very slow. Trees lose their leaves, so we need to figure out how matter interacts with ecosystems, but also how we can use them sustainably. I might even include for this one the use of fertilizers in the agricultural industry. Next one, research the role of experimental device in the development of various atomic model and compare and contrast different models of the atoms. So this one here, I always have the evolution of the atomic model. I go back a couple hundred years when I think of Eurocentric discovery of what an atom is, but I often go back a few, maybe a couple thousand years actually, with respect to having some philosophers, some thinkers from the past, from all continents, including First Nations and more local beliefs. It's very interesting because you see it's all interrelated, even though you go back 2,000 years. It's very interesting. Next one, and here what's interesting, the experimental evidence in the development of various atomic model. So here they want to research the role of the experimental processes, keeping in mind that we know what the atom is, mostly because we had the, how do we call that? We had at some point the philosophers and the thinkers, but the creation of electricity has been the main drive for understanding the atoms and how it is. So we're going to look at the experiments. So here they have researched the role of experimental evidence. So what I might do is talk about the experiments that has been done and see if I can get students to figure out what they've learned. We'll see. Next one, identify the location, relative mass, and charge of subatomic particles within an atom using the Bohr-Rutherford model. So this one here, my students, I always give them a large 11 by 17 page where I have traced the periodic table, the frame of the periodic table, and they have to draw the first 20 the Bohr-Rutherford diagrams of the first 20 elements. Gives them a chance to see how to build them, first of all, but it allows us to understand the trends, the patterns, and it's helping quite a bit. They always like to do that. Explain the relationship between the position of an element in a periodic table and the structure of the atom using models. So here we can use models that are 3D. So we have the molecular kits, but there's some amazing simulations. And last week I was playing with Claude codes, trying to see if I can create an app where you can have two atoms, merge them together, and have the electrons going in the right place. And not quite perfect, but I think that the more I use it, I think the better I will get. And my hope is that I might be able to ask the students to create their own code using, for example, an AI to do that. I'm not sure if it's going to be possible, but I think it's worth the try. Investigate the physical and chemical properties of elements. Use the finding to relate these properties to the organization of the periodic table. Classify the elements and identify patterns in the periodic table. So here we're going to have the different groups within the periodic table. Investigate and describe the physical and chemical properties of elements and compounds, including those that make up a common household product. In the past, I used to do a lab with density. They use it in grade 7 or 8, I think. But what's interesting, I have a metal supermarket not too far from here. And every year I go there and I get a few more pieces of either aluminum, copper, iron, carbon steel. And what happened, I have a lot of different shapes, and I get the students to find the mass and the volume of these objects. And then they create a graph trying to figure out if they can find the density of those metals, which is a physical property of elements or compounds. Now, what's interesting though is that it's a concept from previous years, so I have to see if I can find a different one right there. I remember a few years ago, we used to do the density of different wood. So if you have, for example, alders or poplar compared to maple or oak, different density of wood depending on where they grow. I think that's interesting too. And describe the relationship between the structure of simple compounds and their chemical formulas. So here, that's something that we've been doing. What's interesting here is we have relationship between chemical formulas. It means that they can figure out what the formulas are, but there's no mention here of nomenclature of ionic compounds or molecular compounds. So I think I'm going to include that as an extension activity, keeping in mind that this is a D-stream class, and therefore some students, many students may decide to go to, let's say, college or university, and therefore when they choose their courses in grade 10, they might or might not need that. We'll see how it goes. So that is chemistry for us. Now for chemistry, I forgot to mention what the students will look at in grade 7 or 8. So just so we have a good idea. Now in grade 8, they're learning about energy and matter, and that means that they understand the relationship between mass, volume, and density. So that means that they have seen this. The question here is I'm not sure exactly the type of labs they've done before. So we might decide to do a lab on density just for fun. Explain between solid, liquid, and gases, which is good. We'll talk about that in ecosystems as well. The difference between liquids and gases with respect to pressure. That's not something we're touching in grade 9. And here, determine the buoyancy of an object given its density in a variety of fluid. So here may not be the intrinsic property of matter, like a metal, for example, like aluminum. We'll see. In grade 7, when they look at matter and energy unit, they talked about pure substances and mixtures. So they should have an idea of what a pure substance is, but they focus their grade 7 learning on mixtures. So they have the particle theory of matter, so that's always a good one to review. They're going to look what a mixture is, and then what is the difference between a pure substance. That's very important for us to help with that. They also will look at here, not as much about the saturated solution, but the idea here that they have talked about qualitative and quantitative terms, something important in grade 9 investigations. There you go. And here they talk about describe pure substances as elements and compounds consisting of atoms and combinations of atoms. So here, that's something that I don't remember was in their curriculum before 2022, but that's something they've touched if they were students of grade 7 in Ontario. So that is what we've learned about chemistry here. So let's see what we have the next unit. The next unit for part D is physics, and it's about the principles and application of electricity. So I'm going to close this. Perfect. So in this one here, in this strand, students integrate the learning of strand A, STEM skills, and investigate concepts, develop and apply skills, make meaningful connections related to energy and electricity. So let's see what they've got. So here they have in the specific, the section on relating science to our changing world, it goes like this. Assess social, environmental, and economic benefits and challenges resulting from the production of electrical energy from different sources. So here we're going to have renewable and non-renewable sources of electricity. Evaluate how electrical energy is produced and consumption impact various communities. Now, keeping in mind that if you have some society, there a lot of the electrification is advanced compared to others. However, the more we are consuming electricity, so we have, for example, the electric vehicle industry, the more we need energy. So, is the production of energy, let's see, are being in line with how much we need? That's a good question. And you have to see that easy and quick production of electricity might need gas or coal, which are detrimental to the environment. So that's something to look into. Develop a plan of action to address local and global electrical energy production or consumption and some energy conservation strategies. So here we're going to, I hope in the past, that I haven't done that in a long time, I used to, oh, that's a good idea. I might ask students to go into their home or apartment, or maybe use a friend's home and look at the electric meter. So the energy consumption inside a household, maybe gather electric data for a week or two, and then see how they use electricity. So this one here is a good project, actually. I was not sure if I wanted to do a project on careers as well, so we'll have to see. And here, analyze social, environmental, and economic impact of emerging technology related to electrical energy production, consumption, storage, and conservation. So a lot of work is being done with respect to a variety of sources of electricity, how we can store them. So for example, if you have solar panel or windmills, can we have battery storage using battery so that energy can be used at other times? I know California in the United States are doing amazing things there. And I know that there's a lot of storage technology happening from China, and as well as from Tesla with some storage technology. I'll have to double check that. It's in my mind, I have it from a couple years ago, but I think I need to update that as well. So let's see, what's the next bit? The next bit is part D, related to investigating and understanding the concepts. And here demonstrate an understanding of the nature of electric charges. So here, electrons, so positive and negative charges, including properties of static and current electricity. So let's see what we've got. So here we have conduct investigations to explain the behavior of electric charges in static and current electricity, to relate the observed behavior of the properties of subatomic particles and atomic structures. So here with static electricity, we have often a lot of equipment from a lab with ebonite rods, glass rods, plastic rods, and a variety of cloths. However, I find that sometimes it's hard to see. I often use balloons because students have seen balloons, use balloons, and we can rub the balloons on our hair with permission, and we can see how static electricity goes. Interestingly enough, in the last couple of years, since after COVID actually, a lot of students haven't had a chance to inflate a balloon as well as do a knot on balloons. They know of it, but it seems that balloons are not as much part of growing up as it used to be. Maybe it will change, but I've noticed that it was interesting. And then since we have talked about chemistry and copper, how can we think of available electrons from copper atoms in a wire so we can transfer energy? So we'll talk about that. D2.2. We have determined the conductivity of various materials by investigating their ability to hold or transfer electricity. So here that will be when we talk about resistance. I sometimes include this idea of different materials conduct electricity in various ways. And that would be a good way for us to bring transistors as well. D2.3, identify the components of direct current, circuit and explain their function and identify electrical quantities, symbols, and their corresponding international system of units. Now, what's interesting here, it's the basic components. So we have a source, conductors, charges, and interrupters or switches. The idea here is that we're going to have simple circuits. If you have the equipment, we can do more complex circuits, but you can certainly use PHET simulators that I often include in my class. D2.4, investigate the relationship between electric current, potential difference, and resistance in electrical circuits, and develop a mathematical model to represent the relationship. So here often what I do is I create. So first semester is tricky because you can do a graph with current and tension, and you can actually graph the information and find the resistance. The difficulties, though, is that sometimes students have the math class in the second semester, so I'll have to figure out how we can work on this one here. But with the PHET simulation, we can certainly see the correlation. Apply a mathematical model to calculate electric current, potential difference, and resistance in real-world situations. So for this one here, we can use, how is it called? So when we buy, for example, like a fridge or a dryer or washer, we have the inner guide. Like inner guide will be something that I will look into with us, because we can do the actual calculations with the efficiency of these piece of equipment. There's a word there and I can't remember what appliances. There you go. We can see the efficiency of the appliances. We're going to construct series and parallel circuits to compare electric current, potential difference, and resistance in both types of circuits. So usually I do it in series with the hands-on activities. If people want to go and use simulations for parallel circuits, they can. Otherwise, they can do the hands-on activities without any issues there. We need to explain the difference between electricity and electrical energy. So difference between the other one, and determine the efficiency of various electrical devices that consume or produce electrical energy, and identify the energy transformation in each device. For this one here, there's a quick calculation with respect to how much energy is being used, how much energy is being transferred for useful work, times 100 for the efficiency. So there's a formula that works on this one, and that's something that could be fun, especially when you think of power tools. Power tools is a great way where you know how much energy comes out from the battery, and you can figure out what energy is being produced if you are using the tools. But there's also, with friction, with loss of heat, not all energy that is being used has been transformed into something else. So that's something that I will look into. Perfect. So that is for electricity. Let's look at what they've looked at the past. So in grade 6, when they looked at their unit on matter and energy, they have short and long-term impact of electrical energy generation technologies related to First Nation, Métis, and Inuit communities. And here they also talked about climate change. So they have some thinking about that. Assess choice to reduce personal use of electrical energy. So here will be more about their ideas. Now, I think I'm going to do a data collection in their own home to try to see if they can help themselves. In grade 6, they also looked at the electrical phenomena. So the grade 9 program is in line with what they do in grade 6. And here they've looked at static electricity. They're going to look at the difference between current and static electricity. They will also look at what is a good conductor. And what is the difference with an insulator. So when we look at static electricity and a circuit, they'll know. They also they've seen electrical energies transform, explain the different components of simple electrical circuits. So some of them have done simple circuits. So the question here is, how does it go? Now, keep in mind that the Ontario government also has included some tech classes in grade 9. So that means that part of the tech rotation or the tech class, some students have done or will be doing some simple circuits as well applied to their project. So there's a lot of links that can be done with the tech department here. And here, theoretically, they've seen the difference between series and parallel circuits. To be honest with you, in the last 20 years I've done this course, I think maybe 2 or 3% of the students actually know the difference between a series and a parallel circuits by the time they come to my class. Maybe it will change. We'll see how it goes. So that is the information about the unit on physics. So here's the fourth and last unit for the grade 9 curriculum. So here, let's see what they're going to be learning. It's about Earth and space science related to space exploration. So the first one here is relating science to our changing world and therefore evaluate social, environmental, and economic impact of space exploration and of technological innovations derived from space exploration. So let's see what are some of the key parts, the specific expectations here. So the first one here is to evaluate. Let's see. There you go. Perfect. Is to evaluate the social, environmental, and economic impact of space observation and exploration. So exploration here gives us new technology, but space observations help us with our environments, with the climate change, to better understand our planet. So we're going to be looking in some of these and some of the amazing technology and satellites we have around the planet. We also evaluate how space observation and exploration technologies contribute to our understanding of climate change, natural disaster, and other phenomena. Just talked about this one. And assess ways in which technological innovations relate to space observation and exploration are applied to various fields, including their contribution to sustainable practices on Earth. So that could be about how we deal with water consumptions, how we take care of forestry. I know I was listening to some forestry engineers, and they were talking about how even in May and June, they were predicting the different fires we have in British Columbia, Ontario, and Northwest Territories, just based on the water content of the soil and how dry the environment is. All information that we've collected from satellites. So that's something that is interesting there. We also have the second part. There we go. The second part is about investigating and understanding concepts. So here's demonstrate an understanding of the components, characteristic, and associated phenomena of the solar system and the universe, and the importance of the sun and processes on Earth. So let's see what we've got there. So here, much more related to the specific concepts. We have for the first one, describe the importance of the sun and its characteristic, including the role of the solar system in sustaining life on Earth. So this one here is from the energy of the sun and is a good link with photosynthesis in the biosphere and sustainable ecosystems. Next one, explain how the sun's energy causes natural phenomena on Earth and how these phenomena contribute to renewable energy production. So here we have heat transfer. We can talk about wind. We can talk about the water cycle, allowing us to have wind turbines as well as hydroelectric power plants. All the parts important, all based on the fact that if there's no sun, it would not be possible. Summarize in observational evidence to support theories about the origin and evolution of the universe and the solar system, considering diverse ways of knowing. Now, this one here is interesting because in the past we've had a variety of telescopes. Then we got into the Hubble telescope, and now we have the James Webb Space Telescope, and we have more and more understanding and data of the visible universe. That means that we can look at the information we've got, the theories we have, and sometimes even rethink what we can do. We have described major components of the solar system and the universe and compare their characteristic. Very similar to what they do in grade 6, and I'll have a quick look in a moment. Quantify distances in the solar system, so here with astronomical units, and the universe, looking at light years by applying the understanding of relative distance and sizes and using the appropriate units of measure. And here the last one is conduct investigations to explain the cause of various astronomical phenomena that can be observed from Earth. So they could be easy, similar to the eclipse, solar eclipse, lunar eclipse. Could be about northern lights, southern lights. We can have also, let's see what else. Maybe we have supernovas that we can certainly add. So this is the information from grade 9. Now, before we finish, let's have a quick look at what they see in previous years so that we can minimize repetition. So in grade 6, they look at space. So therefore, they look at how space, let's see, the impact of that conditions, analyze the impact that conditions in space. That makes no sense. How humans engage in space exploration. That's good. Lots of things going on right now. We are planning to go to the moon by the end of the next decade. So by the end of the next 10 years. So it should be something fun. Assess the role of space exploration and the new technologies, and evaluate the social and environmental impact of space exploration. Now, if you think of the Artemis project, they are using hydrogen and oxygen, and therefore the pollution is very minimal. However, if you take, for example, the SpaceX rockets, they're using fossil fuel, and therefore a lot more pollution related to that. The next one, in grade 6, they also look at the different components of the solar systems, asteroids, meteoroids, and such. I usually do an activity when we start. I ask them to create a short video, 30 seconds, telling me about one concept they've learned or they remember from grade 6. So that's a great way to get students to use their creativity to share what they know. We also look in grade 6, they've talked about gravity, so that's easy. We did talk about bodies like stars that create their own light, but also other celestial bodies reflecting light, so you don't have to spend as much time on these. And various technologies used in space exploration, keeping in mind that the more we are exploring, the more we need to miniaturize the technology we have. And therefore, the easier it will be for us in the future. And we don't know, some of our students might create those new technologies in the future. So let's see. So that's basically what I have for the curriculum of the D-Stream Grade 9 in Ontario. It's always good. I review it every year before the semester starts. Gives me a chance to remember what are the important parts, things that I need to add, things that I need to let go. And that's a good habit that you could do to help. On this, I'll see you in the next video. And in the meantime, after watching this video, if you have some ideas in contribution you'd like to share for others, the audience, put them in the comments below. I always read the comments, and I might be able to use some of your ideas to make my classes even better. On this, have a great day. Bye-bye.